So we have the tires of a car making 75 revolutions. We're going to call this delta theta, so 75 revs. And we're going to multiply this by 2 pi radians for every 1 revolution. And this is going to give us 471.2385 radians. We know that the diameter of the wheels is 80 centimeters. Therefore, the radius must be 0.4 meters. We know the initial velocity is 95 kilometers per hour. And we're going to multiply this by 1,000 meters per kilometer and 1 hour for every 3,600 seconds. This is going to give us 26.389 meters per second. Our velocity final will be 55 kilometers per hour times, again, 1,000 meters per every kilometer times 1 hour for every 3,600 seconds. And this is going to give us 15.277 meters per second. At this point, they want to ask what's the angular acceleration. So we're going to say that v equals r omega. So to find omega, we need to say v over r. So when we do omega initial, we should do 26.389 divided by 0.4, and this is going to give us 65.97 radians per second. Our omega final will equal 15.277 divided by 0.4, and this is 38.19 radians per second. Now at this point, if we want to find the angular acceleration and we don't have time, we're going to have to use angular kinematics and say omega final squared equals omega initial squared plus 2 alpha theta, the delta theta. And solving for alpha, we find that this is going to be equal to omega final squared minus omega initial squared divided by 2 delta theta. And this is going to be 38.19 squared minus 65.97 squared divided by 2 times 471.2385. Alpha equals negative 3.070 radians per second squared. So this will be the angular acceleration. And then it's asking us, okay, how long, or rather, how much time does it take? Well, we can say that if this is answer for A, for time is going to equal, rather, we can say that omega final equals omega initial plus alpha t. So we can say that t is going to equal omega final minus omega initial over alpha. We know that this is going to be 0, so this is going to be simply equal to negative 38.9 over negative 0.3070, and this is going to equal 12.44 seconds. So at this point, we should say that in order to find how long the car traveled, we're going to use angular kinematics and say that omega final squared equals omega initial squared plus 2 alpha delta theta, and we can solve for delta theta. So delta theta will equal omega final squared minus omega initial squared over 2 alpha, and we know that this is going to be 0. So this is going to equal negative 38.19 squared over 2 times 3.070. Rather, this is negative. And this is going to equal 237.537 radians. So we found the angular acceleration by finding the initial and final angular velocities. So this was your part A, and then essentially after that, after it reaches 55 kilometers per hour, how long does it take to stop? Given that this angular acceleration is constant, and that would be this answer right here. And then it's saying during that time interval of 12.44 seconds after the car reaches 55 kilometers per hour, how far does it go? So we can find this. This is our how far we go in radians, but now we simply have to multiply this 237.537 radians plus 471.2385. This is how far we traveled in the beginning. This is our delta theta, 471.2385, plus 237.537, how far we traveled after the car reaches 55 kilometers per hour. And this is going to be times 0.4. Because again, this is simply based on the fact that delta x equals r delta theta. So essentially, r would be our 0.4, and delta theta would be our initial and our final. So we can then say that this is going to be equal to 283.51 meters. So this is how far the car travels total. This would be equal to x total. And that's the end of the solution. Thank you for watching.